after the webinar, both via YouTube and on the LRWP website. So welcome. My name is Heather Fennick. I'm on the board of the Lower Raritan Watershed Partnership. We're located in central New Jersey and do work in the 54 municipalities that drain to the Lower Raritan Watershed. And I'm super pleased to welcome Isabelle Stinnette for a conversation today with us about habitat connectivity. So Isabelle has joined us a couple of times before for presentations and conversation and strategizing about how to improve habitat connectivity in the Lower Raritan. She is the restoration manager at the New Jersey Harbor and Estuary Program, where she runs the Interagency Restoration Work Group, tracks restoration progress in New Jersey and New York, and works with partner agencies to further habitat restoration efforts. Prior to joining HEP, Isabelle worked for the New York State Department of Environmental Conservation as a restoration biologist, as well as a research technician expediting storm recovery and resiliency projects. Isabelle has a MS degree from the School of Marine and Atmospheric Science at Stony Brook University and a BA from St. Lawrence University. So welcome, Isabelle. Thank you so much. We're glad to have you sort of continue to advance our conversation about habitat connectivity and keep it fresh in our minds about why we're doing so much of the work that we're doing, the big picture piece of the puzzle. And I'll let you introduce yourself a little bit more and then your project, and then you also have the ability to share your screen, and we'll let you walk us through your visuals.
Great, thanks so much, Heather, and thank you for having me. Again, everybody, we're a small group, so feel free to jump in and ask questions along the way. That'll make it more engaging for all of us. And, especially, towards the end of the presentation, I'll get into some of the more like local knowledge. And I'd love to hear from you guys if you have any just, kind of local experience with any of the areas I'm talking about on the Lower Raritan. That would be really cool. So let me just share my screen real quick here. Okay. Good. Okay. Okay. So yeah. So we call this project Aquatic Connectivity through Climate Ready Infrastructure, and hopefully that's a good enough title that you can kind of understand what we're going for with this project, which is both looking at aquatic connectivity for like fish and other aquatic animals that use the streams to migrate, and also look at climate change and flooding vulnerability. So yeah, so this is partnering with the Rutgers Sustainable Raritan Initiative, which has been a really great partnership. So I think most people probably know what the New Jersey Harbor and Estuary Program is, but if not, I just like to add in this slide. This is a big blue map here is where we operate. We tend to focus a little bit more on the kind of harbor part down in the urban, more densely populated area. But as you can see here, our jurisdiction really goes all the way up to Albany in New York and goes out to the Raritan headwaters in New Jersey. So we are one of the nation's 28 national estuary programs. There's a lot of us, and we're managed by the Hudson River Foundation. So if you ever hear the Hudson River Foundation and HEP are the same thing. It's kind of confusing, but we're all one big happy family. Yeah, so these are the two kind of factors, the major programs that I've brought into this project. One is the North Atlantic Aquatic Connectivity Collaborative, and these are the folks that they really set up a really awesome training program and rigorous protocols and open database all throughout the Northeast. It's very popular. Everybody's kind of on the same page with using this particular protocols to get their to take their aquatic connectivity assessments. So it's been really great to use that and take advantage of that. And then at the same time, I'm using a model from the Cornell University Water Resource Institute, which is the model that looks for issues with hydraulic capacity of these road crossing structures. So we're talking basically bridges and culverts throughout the watersheds. So we're looking at the same structures for both the aquatic connectivity, and then we can use that data, and it goes right into this other model developed by Cornell, which looks at the capacity issues and the flooding and erosion issues. So just a little bit more background on aquatic connectivity. So what do fish like? They like, as much habitat as they can, whether you're a happy alewife, which is an anadromous fish, which is a fish that spends part of its life cycle out in the ocean and then comes up into the tributaries at certain points in their life to spawn. Or your happy brook trout, which is a patadromous fish, and patadromous just means that it's a migratory fish. They go up and down throughout the freshwater reaches of streams. They don't go like all the way out to the ocean like the anadromous ones do. So they want, these fish move along around quite a great deal. So they want as much habitat as they can reach, and they also want good quality habitat, which I know the Lower Raritan Partnership does a lot of work already on trying to analyze good riverine habitats, and that's really important as well. So what do they like in their crossing structures? So these are the kind of things that the NAC assessments, the aquatic connectivity assessments look at. So they like natural substrate, is the crossing structure, is it a concrete pipe? Is it metal? Or is it like a nice sandy, silty bottom like it would be for the rest of the stream? They like low velocity. So a lot of times when you have a structure that is not a natural bottom, or maybe it's undersized, you get these really high velocities coming through the crossing structures, and the fish don't like that as much because it's harder to swim down. They don't like having to jump up a falls if they can help it. A lot of fish can't do that, only certain ones can. And so, if you're seeing a falls coming out of a culvert, that's a major barrier to connectivity. So definitely the assessment considers that. It also looks at light. I think a lot of animals prefer well-lit structure because so they know what they're getting into. And it has to have adequate depth of water for the fish to be able to swim through. So sometimes you'll get a lot of erosional issues, or culverts that are up too high and it gets super shallow. So that's not good either. So these are some of the things that you look for in the assessments. Heather, I don't know what's it going to do if somebody raises their hand or anything, because I can't see anybody.
I'm paying attention to that, and I don't see any notes in the chat box or any hands raised, but we also have folks unmuted for the most part too, so they can pipe in.
Okay, cool. So the other part is the hydraulic capacity modeling. And like I said, it's designed to work with the NAC data and bring that in right from the output of that first model. It also looks at, it's a GIS model, and you look at elevation and also the precipitation in a given area. And then what it kind of comes up with is, you can see the maximum storm event that the crossing can accommodate without causing erosion or flooding. So you can kind of see from this, the Cornell Water Resource Institute put together this cool video in modeling a stream, but I just took a snapshot here that you can kind of see when you have a natural stream bed and then you put in a culvert that's undersized, you can get erosion upstream and erosion downstream, which are, they're both problematic. So if you're not familiar with the maximum storm event, this is just, it's basically, you can think of it as a probability given all the precipitation events that you get in a region. So your 100-year storm event, that usually has about a 1% chance of occurring every year. 50-year storm event has a 2% chance, and as you go lower and lower, you get it's higher and higher the likelihood of having a storm event of that size. So I think generally you want to have like for a crossing structure, for a roadway, for example, you want to have over at least a 50-year storm event, just as kind of good practice. So when you hear those storm events, that's what they're talking about. So this slide has a lot. I'll just kind of go through it slowly. So, you know, when I was first looking at this project, I needed to know where to start. So I know I wanted to focus in New Jersey because there's already a lot of really great connectivity work going on in the Lower Hudson with our sister estuary program, the Hudson River Estuary Program. So I wanted to make sure I focused my efforts in New Jersey where there was a little bit more need. So I basically broke down our area of New Jersey that works into these little sub-watersheds. So that's what you can see on the colored map here. All these little parcels are your sub-watersheds. And then I did a prioritization, and I did prioritization based on all the things on the list here to the left. NAC came up with its own prioritization, so I used that. I used the head of tide because I wanted to prioritize streams that could be really important for anadromous fish, for the fish populations that need to go in from the ocean. I looked at a data set called, from a group called Nature's Network. I looked at the connecting habitats across New Jersey from the New Jersey DEP, which if you haven't checked that out, I will recommend that you check that out. It's a really great program. They're looking at primarily the same crossing structures, but more kind of geared for terrestrial animals and connectivity. And so that we can make sure that our culverts and our bridges are kind of doing double duty and allowing that the wildlife doesn't have to go up on the road. So that's a really, really great program. I also look at social vulnerability. That increasingly, at least my organization is looking to work as much as possible in areas of higher need, and making sure that, you know, if I'm doing something that could potentially bring in funding to our region, that I'm focusing on an area that needs some love and needs, you know, is disproportionately affected by environmental justice issues. So I wanted to factor that in. I looked at our comprehensive restoration plan and identified sites where the Army Corps had already identified potential tributary connections issues. And then I also looked at the planned projects from the transportation infrastructure priority list. So this is a list of, you know, basically the desires from the transportation sector in New Jersey of projects they want done, with the idea that if they're already doing a construction project or they're already going to redo a culvert or a bridge, I want to make sure that I can analyze that area first and get to those projects so that I can recommend how to do that kind of restoration in a way that's going to be beneficial for the aquatic connectivity and the flooding issues. So,
Isabelle, how long did the prioritization study for you take, you know, working through all these different metrics of need?
you know, they're not too long. They're all established data sets that I was able to find on already on GIS shapefiles. So it was basically just a kind of a layering exercise, layering them on top of each other, and then kind of creating a scoring rubric. So it's not, you know, it's still prioritization. It's not like an exact science, but it really gave me a starting place of, you know, where to focus my attentions. So I should also say the colors are just percentiles of the of the score I came up with. I just took all the scores and then I, chopped them into, 10th percentiles. So the watersheds that are the darker reddish orangish colors are the higher priority, whereas the dark blues are the least.
Great, thank you. And just for attendees, I did put into the chat box an example of one of these metric approaches, the change, that's the Connecting Habitats Across New Jersey NJDEP tool, just as sort of an easy site to look through and see how they are doing habitat connectivity assessments.
Thank you. So then I started off in 2019 with, I got, kind of a beta testing. I did a site up here. I think you can see my mouse up here on the lower Passaic up in like Clifton. And then down here on the lower Raritan, and this is in partnership with Rutgers. And then the next year, COVID hit, so not as much done as I might have liked, but I still did site out here on the upper Passaic, and that was in partnership with the Great Swamp Watershed organization. And then following that, I applied for a national grant from EPA, and it's administered by Restore America's Estuaries, and I got that grant to do the assessments for this project that I'm going to give you more of the results of. And that's in the Lower Raritan and South Rivers here. And so this South River portion right here is what we focused on this past summer. And then shortly this summer, we're going to be starting on these kind of red subwatersheds here in the Lower Raritan. Yeah, so there's just a little bit more about that coastal watershed grants. We'll be assessing over 350 crossings in 11 subwatersheds, so it's a pretty big project. Working with the Sustainable Raritan Initiative, it's been a really great partnership so far with Rick Lathrop and his lab, and different groups of Rutgers students have been helping out throughout the 2 summers. So yeah, so it's really great to have them in the field. And also as part of the grants, it was exciting to kind of take the assessment to the next level. So I put in for some funding to contract with a design and engineering firm to work towards, getting an actual restoration project going. So taking these kind of recommendations that I'm able to make through the assessments and say, okay, what do we need to do to get it up to 30% design? And also to create kind of a toolkit for the rest of the problematic crossings so that we can know what we might want to do for those as well, given, more funding opportunities in the future. So it's just a little slide showing some of the summer field work. This is all the sites that they did last summer on this map. There's a million of them. And what it takes in the field is long, hot, muddy, poison ivy days. And sometimes the streams are really nasty. Sometimes the streams are really gorgeous and beautiful, but kind of got to be prepared for everything. And this is just an example of our field data forms. They go on for a few more pages, but you can collect data through by paper forms or through a tablet, which makes it a little bit easier. And now I'll go a little bit into kind of what I do with the data and kind of the next steps in evaluation. So the first thing is to get all this assessment data. So that's all the really rigorous field work. There's photos taken at every site. It's pretty labor intensive. And then that data goes into the Cornell hydraulic model, which I was telling you about for looking at the capacity modeling for the culverts to look for flooding and erosional issues. And the output you get from that is the maximum storm interval that each crossing can handle without, flooding and erosion. And then it also kind of bumps the precipitation up. So you can look at the same crossings, well, what would happen under increased precipitation scenarios with climate change. So that's really helpful as well. The next thing I do with the data is look at the Dendritic Connectivity Index, and I'll tell you a little bit more about that in a second. But basically, the Dendritic Connectivity Index is a way to look at aquatic connectivity on a kind of a watershed basis, and try to figure out where you're going to get the most bang for your buck, restoring which part of the watershed is going to give you the best results for connectivity in general. And you can look at this both for the diadromous fish, the anadromous fish that go to the ocean, and the petadromous fish. It's kind of two different versions of the analysis. And then finally, I look at infrastructure condition. I think that's important to weigh into the results, because if you know, one of your culverts looks like it's got pretty good passability, but it's crumbling and it's falling apart, that doesn't help anyone either. So I think, you know, it's important to be realistic and try to replace the culverts and bridges that really need replacing structurally. So here's an example.
Let me just say, that is just such an elegant presentation of how everything sort of fits together. So I think that's just a real nice model and very clear.
Thank you. So here's the here's what the results look like when they come out of the passability assessments for aquatic connectivity. So you basically have some culverts and bridges that are no barrier whatsoever. You know, it's just like going up and down the stream for the fish. And then they go from insignificant all the way up to severe. And what's interesting to keep in mind about this is a few things. One, that, you know, these are the results for everything we did last summer. So all of the data combined. So most of them, at least half of them, are pretty much just fine, which is good. And so those, I wouldn't prioritize any of those for restoration. And then these severe barriers, a lot of the time, I wouldn't prioritize these either, because a lot of the time these severe barriers, it's not super realistic that these would get restored or upgraded, because a lot of them are places where the stream will go into a storm sewer, and it just disappears, or it goes under like a big housing development for 5 blocks and then reappears, you know, later. So these are like huge projects that are not likely going to you know, get a lot of interest in, you know, people moving, you know, 25 houses to, you know, restore fish passage. So I try to keep a little bit of realism. So most of the time when I'm looking for so good prioritization projects, it's over here with the minor to significant barrier projects. And another thing to keep in mind is that this data does not include dams. So there are dams everywhere, and dams in all of the work I've done in all of the watersheds so far, dams have always been the worst barrier. So they're always the most significant barrier in the watershed has always been the dams. So still important to keep in mind. So here's a little bit more about the Dendritic Connectivity Index. I find this diagram helpful, but I think, you know, it might be a little bit confusing. So this is a diagram of one of the subwatersheds. So it goes from down here where it says Matchaponics, that's the mouth of this tributary. That's where it hits the South River. This, by the way, is the most complex of all the subwatersheds. And then this way up here is the upstream, where it goes into a different subwatershed. And along here, these are all the kind of tributaries and junctures, and each one of these blue or white little boxes you see, that's no barrier whatsoever for fish or aquatic passage. So there's no problem here. The only problem is when you hit either one of these reds or the yellows. So the Dendritic Connectivity Index is very much like looking at the subwatershed as a whole and trying to think about, as a whole, how do I improve connectivity? And the assessment for this is basically you take all the problematic culverts and bridges and you multiply their passability score that you get from NAC times how much habitat you would free up to the next barrier upstream of that if the barrier wasn't there. And then you sum that up for the entirety of the watershed and you get what's called a DCI score. And the DCI score is basically a score that represents the connectivity for the whole of that subwatershed. And then once you have that DCI score, then you can play around with it a little. And then you can say, well, what would happen to the DCI score as a whole if I restore this culvert, or what would happen to the score as a whole if I restored this culvert instead? And you can see where you want to spend your energy to make the most difference to connectivity as a whole. So any questions about that? I know it's kind of a new concept for a lot of people. Good.
I don't see any hands here, but Isabelle, can you describe what perhaps some of the low-hanging fruit might look like in terms of the restoration processes, maybe?
Yeah, none of it's terribly low-hanging fruit, except for maybe if you see the kind of lowest hanging fruit you'll see is when you see a culvert that's blocked by like natural things like sediment or debris or rocks or something like that, where it's like, oh, maybe all we need is to clean this out and then connectivity would be okay. So that's probably the lowest hanging fruit, although I don't see a lot of that. And then you also kind of got to think about, well, is there a reason why all this debris and sediment and stuff is accumulating in here in the first place? So, but for the most part, all of these, restoration projects are going to involve like, going to design and, like dealing with the, partnering with the transportation sector, like your municipality or your federal highways or, your county roads or whatever it is. So, but yeah, I think, I think the end goal here is to really, help some of the stakeholders, the people who are doing like watershed-based planning, and let them know, where's the best places to focus.
Great, thank you.
So in this slide, I showed you the large numbers I've pasted over the watersheds here. These are the 6 watersheds that we did last summer. So these are their DCI scores, and the DCI scores go from 0, which is the worst connectivity, to 100, which is the best connectivity. So so I can explain some of these differences, which are, up here in this watershed I call it the South River watershed. It has a nice open main channel, and most of the problematic issues are way up on these little tributaries. So it allows for quite a bit of connectivity, and it also connects down to the Raritan River, which is great, good for anadromous fish. These ones down here, this is Machaponics, and this one is Barclay. And these have higher scores because they're super, what they call dendritic. They have a lot of branches. And the more kind of branches you have, leads to better connectivity. Whereas up here, like these two that have the score of 11 and 19, they're not quite so branchy, and they both have huge dams right pretty much at the mouth of these watersheds, which really affects the connectivity score in a big way. Okay, so here's just some more of the results of last summer as a whole. So as I mentioned, I have 4 basic factors that go into the overall score, the evaluation. One is the NAC score, the aquatic connectivity score. One is the hydraulic capacity score, that's that maximum storm interval. One is the dendritic connectivity analysis, and then the final is the condition. So is it falling apart or not? So it's those 4 things I'm looking at for the overall score. So so basically, I think they're all weighted equally. So, whichever has the worst of all of them ends up as the worst score and gets the kind of higher overall score. So you can see here on my x-axis is my overall score, and with 0 being like good, honestly, and the 1 being like have the most need. So these crossings that happen to fall in this triangle here are the ones that I would choose for priority for restoration. So you can see when you look at it compared to the passability score, most of them down here do have poor passability scores for fish, but then there's some up here that actually aren't so bad. And so these culverts up here are probably problematic for other reasons, like they're falling apart or they're super undersized and they're causing flooding issues. And so you can look at the same thing over here on this other graph. With this one, I'm looking at the overall score compared to the capacity, the culvert capacity issues, so the flooding and erosional issues. And most of them are down here, but there may be a couple that are actually right-sized, but they're not good for fish for other reasons. And here's another way to look at the data. Not sure whether or not this graph works. You guys can tell me. So basically, each one of these triangles, the colors represents a different one of the 6 watersheds that we assessed. And as you go kind of further out on each of the axes, it represents more need for that particular thing. So, so the ones that are higher up to the edges out here have a greater need for capacity. They're undersized. So you can see the Tenant and the South River have a lot of undersized culverts. Average need for fish migration over here at your east directional. These are ones that are important to do for dendritic connectivity issues for fish migration. Down here at the bottom is the passability, so just the general NAC scores. The ones further out have the worst NAC scores. And then over here to the west, you have the ones that are most in need of conditional, like, falling apart, crumbling infrastructure needs. So you can kind of see that all of the watersheds, they kind of develop their own character. So I will get into that a little bit now, which will basically be the end of my presentation. Oops, too far. So I'm going to start up here with the South River, and I'll say that I'm just going to go through these briefly, but I've written a fact sheet with for each one of these subwatersheds, and I'll give you the link to my website wherever I've posted them. So if you have a particular local interest in one subwatershed or another, you can look at the fact sheet, and the fact sheet lists, all the things I'm going to tell you now, plus also gives you the list of all the recommended culverts or bridges to upgrade within that watershed. So the South River has good connectivity overall. It's important for anadromous fish being right there by the Raritan River. There's a lot of migration possibilities there. Nearly all of the crossings that are not on the main stem are undersized. So the ones that are on the main stem of the South River are just fine. They're nice big crossings. Nearly all of them that are on the smaller tributaries are way undersized. But the saving grace is that it's kind of not a residential neighborhood. It's so flooding is a little bit less of an issue up where these are because it's a little bit more rural. And there's a lot of railroad crossings in this, problematic railroad crossings in this subwatershed, and also ghost crossings. So ghost crossings are a pet peeve of mine. Ghost crossings are crossings that we find that aren't on any currently used infrastructure. So they're historical sites that basically are blocking flow and, causing issues and blocking aquatic connectivity, but they're no longer roads or trails or railroads or whatever they are. They're just literally, bridges sitting in the woods doing nothing. So the next is the what I call the Tenant Subwatershed. This is an old bridge. This is mostly the subwatershed is on the Perth Amboy Waterworks property, so there's not that many crossings. It's kind of a nice rural area. Unfortunately, there's this one crossing which you can see in this picture right here, which is pretty funny. It's a lake that is in the middle of the stream, the Tenant Brook, and they have sluice gates under this road. It's the service road that they use for the Perth Amboy Waterworks, but they don't open the sluice gates. And so literally when the pond gets high, it just runs right over the road and goes down this little ramp and then into the river on the other side. So it completely blocks all connectivity right there. So this would be, a good project for some sort of, I don't know that they could remove this, but either removal or, fish ladder or something like that. And it also has some undersized culverts.
Does this have bearing on, that Perth Amboy Waterworks property is a drinking water source? So does this have bearing on or an impact on water quality for drinking water?
I think, well, I think they would never get rid of these ponds because I think these ponds are kind of like, I don't know that they're drinking water sources, but they're like backups of the backup of the drinking water sources. So I think it's important that they have these, but the river runs right through it. So, I don't see any reason why, it couldn't still be an area for fish passage.
Great, great.
So yeah, so might be able to find some good partnerships there. And I forgot to describe on my this photo. This is a really good example on this last subwatershed in South River of a culvert that's like they call it a little bit perched. So it's super deep on the inlet, it's super deep on the outlet, and then inside the culvert is really super shallow. So, you can see that, it's still running. Theoretically, it could pass some fish, but it's really undersized, and that's caused erosional issues on both sides. So it's a real life example. Okay, so this is the other property that has a big dam. This is also on the Perth Amboy Waterworks property. This is the Deep Run Subwatershed on Old Bridge. Aside from, and this is dam, you can see there, and the people who work at the waterworks, they said they do see fish there, and they have like caught fish and stuff like that. So there are fish up in this lake if we can find a way for them to get up and over this big dam. Aside from the big dam that's right at the mouth, it's pretty good connectivity. This stream has a nice riparian area. It's probably pretty good quality. Based on its riparian area. I'm saying that, I haven't looked into that, but, and then there's another stretch kind of up near the headwaters where it's nearly a mile stretch that's buried under a neighborhood in Old Bridge. So that's another problematic area. And this one, I couldn't run the hydraulic capacity model on most of the crossings because they were either too large, so nice big bridges, which is good, not problematic, or they were like this buried stream stuff, which you can't run the model on that either because there's nothing to show. So yeah, that's that one. The next is Earsick. That's in the municipality of Old Bridge. This subwatershed runs into the Diurnal Lake Dam on the South River. The Diurnal Lake is dammed. So I think from here on, kind of up in the watershed, we're not really talking about issues with anadromous fish, because I think that's a full stop. Or at least I suspect it's a full stop for maybe everything besides eels. As well as far as connectivity from the ocean. It is highly dendritic with lots of small streams. A lot of them are ephemeral. So we went to them in the summer. When you do the assessments, it's during low water. And they were dry, but these doesn't mean that these aren't like, active corridors for aquatic passage during other times of the year. The connectivity is good at the headwaters of this, and then there's a lot of buried crossings or like super long culverts up towards the mouth nearest Diurnal Lake. This crossing here that I'm showing in the picture was like, it's not terrible otherwise, like it was a little bit undersized. There's no waterfall or anything like that, but it was almost 300 feet long. And so I think that's a real deterrent for fish and other aquatic organisms. So there were some capacity issues. There were small crossings, but they're also pretty small streams. So that kind of evened out a little. Barclay Subwatershed, I really like this one in terms of restoration opportunities. This one in the picture here is one of my favorites. There were two basically culverts that look just like this in the same neighborhood, one after another, that are totally eroded, totally blocked up. The culverts themselves were like misshapen and warped, and it was important enough for connectivity that I think this would make a really great restoration project. There were already, like, you could see there was some kind of haphazard erosional prevention measures. Like there was a bunch of rocks dumped on one side of the road, and so it's definitely I think this would be a good one for the town. And then and there was less undersized culverts in this one. And then this is my last one. This is the Machaponix. This was the largest and the most complex subwatershed. Connectivity is pretty good. As I said before, it's highly dendritic, so lots of these little streams going everywhere. This is one of the only subwatershed where the folks from Rutgers doing the assessments actually saw a good amount of fish. There was the fish were kind of strangely absent for a lot of the other watersheds, but they did see some interesting fish species in this watershed. Hydraulic capacity was generally good with a few problematic culverts. This picture here is one of my favorites. There are these pictures. This is the same, if you can believe it, this is the same crossing structure. This is the inlet shown on the left. It had 3 different streams coming into it, like one coming out of this pipe here, one coming kind of down the hill, and another coming in through like a drainage ditch on the other direction, just pouring into this clogged culvert. And I went during low flow periods, and and the water was just pouring in from 3 different directions into this little tiny culvert. And you can see, so this other picture, this is the outlet. So you can see it's really rushing, it must be rushing through this and causing this huge kind of lake at the outlet because of all the erosional issues. So this is a really good, this would be a really good one for upgrade as well. And so, that's mostly it. So we have a whole new field season coming up soon with a new batch of students from Rutgers. It's a little bit less work than last season, so that'll be good. And then I'm working now with trying to choose an engineering and design firm to do the next phase of that design project and creating that toolkit. And then, doing as much as I can, outreach, distribution. I'll be creating more of those fact sheets for the new subwatersheds. and I'm trying to get the message out to stakeholders and the people who actually kind of make these decisions in the watershed and, you know, can do some of this planning and operational work. So yeah, that's basically it for me.
Well, that was just this is such important work. Yeah, I think this is such a really, as I said, not only elegant design but elegant framing for the type of restoration that we need. I'm seeing some clapping hands, float through the screen. So I think folks really appreciated this. Some of the people that are listening in right now are stream monitors or pathogen water quality data gatherers. And so they've seen some of these places up close and personal. Maybe not exactly the same sites that you've been assessing, but they've definitely seen their share of problematic, choked up areas. What in terms of sort of helping organizations like the LRWP support municipalities in they're often the ones that are going to have to take charge of making some of these retrofits or changes. How can we best position ourselves to support them? How can we help them do the right thing in this work?
Yeah, I think that's a great question. I think, you know, part of the missing piece is like, frankly, you know, the community members who live in these areas. And, you know, you never want to do a restoration project without knowing that it's kind of popular with the folks that are actually going to deal with it. And that you're not, it happens more so, I think, with dams, probably than with culverts and bridges, but people grow attached to their infrastructure, right? So, you don't want to, you'd be accused of taking away someone's waterfall when, what you're really trying to do is like, you know, help fish and, ease the flooding in their areas. So, yeah, so I think I haven't personally figured out really how to kind of bring the community into the conversation. And I think that definitely needs to be done. And yeah, and as far as I think also, building relationships with kind of the transportation sector and making sure that they're on board is another key feature. And make sure that they have all the information and they don't have any questions or doubts about the information. I think is another kind of big need in this project too. Up in the in New York State, they're taking these and their connectivity assessments. They're trying to work with municipalities, and I think they're actually giving grants for municipalities to come up with these kind of municipal action plans with respect to your stream infrastructure. So that's another avenue if we can I don't know, try to convince the DEP or work towards that.
So, well, I definitely want folks to feel free to ask questions. I see one here from Frank. He says, Isabelle, when projects to work on, how do you identify what is your info received by those responsible for the infrastructure? For example, municipalities.
Well, I think I'm in the process of figuring that out. I think, it's easier for me personally to do the kind of project management and do the research and, to come up with the numbers. But I think, it's definitely a key element that I think I'm still figuring out. But I think also there's an angle to try to work through resiliency planning. I know a lot of municipalities are kind of keen on doing resiliency planning efforts now, so I think that's definitely an avenue.
Yeah, and along those lines, Isabel, I think that a presentation like this would be well placed at like a planning conference. I know it might seem perhaps not quite like the best fit, but I think the planners would do well to have their ear to the conversation that you're pushing. Yeah, so I think that'd be a great venue. But also to your point regarding getting community members hooked into this and sort of understanding what this is all about. Would you be possibly willing to host a field visit or a site visit during one of your sessions this summer? And the LRWP could bring folks out for a field trip.
Yeah, absolutely. Yeah,
Great.
that'd be great.
So maybe we could figure out a relatively accessible location and get that on the calendar with your team and learn about things in the field. I think that would be really great.
Yeah. Yep.
So are there other questions? So Isabel, would you mind putting your email address in the chat box? Yeah, I can do that too. And then folks, if they want to follow up with you, we'll have that. And as I said, we'll make this recording available both on the LRWP website and on our YouTube channel. And we'll share out in our June newsletter with our larger audience. And hopefully this will start gaining some traction and folks will start paying more attention to this. Really is wonderful work. I think it's very foundational for the conversations that we need to be having about our restoration. So you're so appreciative to you for helping do the big picture thinking about this. So I'm seeing some thanks in here and more applause. So thank you so much, Isabel. I'm going to stop the recording now.